Now we're going to move to some review on empirical and molecular formulas. So review on empirical or molecular formulas. Okay, and again, really, you just the keys here is remembering that the empirical formula is the simplest whole number ratio. So again, let me just go ahead and just give the examples. CH2O versus a molecular formula would be C6H12O6. The difference is we need to know that factor. So if you know your empirical formula, you can determine your molecular by knowing that factor, okay? So let's quickly solve for a empirical formula. Again, I don't know whether or not this is a real formula or not. I've made this up, but let's say we have something that has 76% iron, 17% oxygen, and 7% fluorine. If you're following along in the notes, you know that this is one of the ones that I gave you. And again, I just made this up. And I want to know what the empirical formula is. Okay? So, we've got our percentages. The first thing we want to do is solve for grams, or in other words, change the percentages to grams. So, 76 grams of iron, 17 grams of oxygen, 7 grams of fluorine. Now I've got my grams. The next step is to solve for moles. So convert to moles. So X line, X line, X line, grams, moles, grams, moles, grams, moles. Notice I haven't even thought about a number yet. I'm converting and I need to use numbers to solve for, but I didn't even think about it. I just want to think labels first. The number for moles is always 1. The number for grams, I need to look off the periodic table. For iron, it's 56, oxygen is 16, and fluorine is 19. Okay, so now I'm going to solve. And I've already done this one. Certainly, if you want to see it, let's say we go 76 divided by 56. 76 divided by 56 equals, and again, I'm dividing because that number is in the denominator. So here we go. What did I get? 1.36. 1.36 moles. This would be 1.06 moles. This is of iron. This is of oxygen. And 0.37 moles of fluorine. I'm a big fan of writing the whole label out because I still have moles. Notice my gram canceled, but I get moles. I write that out so that I don't think about rounding here. Our next step is to round to the simplest, Our next step is to divide by the smallest. Sometimes people forget to do that step, and so I'm a fan of writing the labels because then it tells me, all right, I don't have moles yet, but if I divide by the smallest moles for all of them, I'll get no label. And that makes sense. No label, no units, because those are ending up being the coefficients. Excuse me, the subscripts. So 1.36, I get 3.67, I get 2.87, and I get 1. Of course, so I'm dividing something by itself. And I have now to round 4, 3, 1. So my empirical formula will be Fe4O3F. This is my empirical formula for this one. Okay, I'm going to go right ahead and solve for another one and solve for a molecular formula. If I wanted to, and I didn't ask for molecular formula, if I wanted the molecular formula, then really all I'd need is a factor, let's say 2, and I could get my Fe8O6F2. But again, I didn't do this, and to determine this, you need the molecular mass, and I didn't give it. So, but let's go ahead and solve for one of those. So a molecular formula, and again, this is the review here, but let's say that I have a problem that says that you have vanillin. Vanillin is a compound that's flavoring in vanilla and whatnot. and its concentration, its percentages are 63.2% carbon, 5.3% hydrogen, and 31.5% oxygen. Okay, the molar mass, molecular or molar mass, is given approximately 152 grams per mole. Okay, what is the molecular formula for vanillin? Okay, all right. All right, so I don't have my empirical formula, so I need to solve for my empirical formula. And again, first step, change those percentages to grams. So 63.2 grams carbon, 5.3 grams hydrogen, 31.5 grams oxygen. All right, once I have my grams, I convert to moles. X line, X line, X line, grams, moles, grams, moles, grams, moles, 1, 1, 1. Notice again, I didn't even think about numbers until then, and now I look to the periodic table for each of these. Carbon is 12, hydrogen is 1, oxygen is 16. Okay, now I'm going to go ahead and divide these. I get 5.27 moles of carbon, 5.3 moles of hydrogen, and 1.97 moles of oxygen. That's my moles. My next step, again, this is a step that sometimes people forget, divide by your smallest moles. That makes sure and that gives you confidence that you're always going to have the simplest whole number, because you always have one that is 1. All right? So there's the 1. In this case, what do we get? 2.68 and 2.69. These are then rounded to 3, 3, and of course 1. So my empirical formula is C3H3O, but I'm asking for the molecular formula. The molecular formula, you take the molar mass, which is given 152, and divide it by the empirical formula mass. So let me just C3H3O. Carbon is 12 and I have 3 of them, that's 36. Hydrogen is 1 and I have 3 of them, that's 3. Oxygen is 16, I only have 1 of them. Add that all up, that'll be my empirical formula mass, which is 55. I put that in the denominator. I take my given molar mass divided by my empirical formula mass, divide those, I get 2.76, which I now round to 3. This becomes the factor that I multiply by my empirical formula, and so therefore my molecular formula is going to be C9H9O3. And this is my molecular formula for vanillin. Remember this one.